Every bridge tells a story. Rope bridges. Long before steel cables and concrete towers stretched across rivers, people relied on nothing more than ropes, vines, and determination. In some of the world's most rugged mountains and dense forests, crossing a deep gorge could mean the difference between survival and isolation. Ancient communities discovered that twisting together strong plant fibers created flexible ropes capable of supporting simple bridges. Wooden planks or woven branches were often added to make crossing easier, while handrails offered a small measure of safety above rushing rivers far below. Some of the most famous rope bridges were built high in the Andes by the Inca civilization, where entire villages depended on them for trade, communication, and travel. Although they swayed with every step, skilled builders replaced the ropes regularly, using traditional techniques passed down through generations. Even today, a few of these remarkable bridges continue to be rebuilt by local communities, preserving one of humanity's oldest engineering achievements and proving that simple materials can overcome extraordinary natural obstacles. Beam bridges. Sometimes the simplest solution becomes one of the greatest inventions. A beam bridge is nothing more than a sturdy object placed across a gap, yet this straightforward idea changed the way people moved through the world. Early humans laid fallen tree trunks across streams, while later civilizations used carefully shaped wooden beams and large stone slabs to create stronger crossings. As villages expanded, beam bridges allowed people to transport food, livestock, building materials, and supplies more safely than ever before. Their design depended on strong supports placed beneath the bridge, making them ideal for crossing short rivers and narrow valleys. Although simple in appearance, beam bridges remain one of the most common bridge types even today. Modern highways, railways, and city roads still rely on the same basic principle, now built with reinforced concrete and steel instead of logs. It is a powerful reminder that some of history's greatest engineering ideas begin with the simplest observations. Arch bridges. The invention of the arch transformed bridge building forever. Instead of forcing a bridge to resist weight from above, an arch redirects that force into its supporting foundations, creating a structure that grows stronger under pressure. Ancient Roman engineers perfected this remarkable design, using carefully cut stone blocks that locked together without modern cement. Their bridges carried armies, merchants, and travelers across rivers throughout the Roman Empire, many surviving for nearly 2,000 years. Unlike wooden bridges that often decayed or washed away, stone arch bridges could endure floods, harsh weather, and constant use for generations. Beyond their incredible strength, they also introduced a timeless elegance that still inspires architects today. Even in the modern world, arch bridges continue to span rivers, valleys, and highways using steel and reinforced concrete, proving that one of humanity's oldest engineering breakthroughs remains one of its most enduring. Truss bridges. As the Industrial Revolution transformed the world, bridges needed to carry far heavier loads than ever before. Steam trains, horse-drawn wagons, and growing industries demanded structures that were both stronger and longer than traditional wooden or stone bridges. Engineers found the answer in the triangle, one of the strongest shapes in construction. By connecting dozens of steel or iron beams into repeating triangular patterns, they created truss bridges capable of distributing weight efficiently across the entire structure. This clever design used less material while supporting tremendous loads, making it ideal for railways and expanding transportation networks. During the 19th and early 20th centuries, truss bridges appeared across rivers, valleys, and busy trade routes around the world. Many became engineering landmarks that connected distant communities and fueled economic growth. Even today, countless truss bridges remain in service, proving that a simple geometric principle helped carry the Industrial Revolution into the modern age. Cantilever bridges. Some rivers and deep valleys were simply too wide to build bridges using traditional methods. Temporary supports placed in the water were often impossible because of strong currents, extreme depths, or busy shipping lanes. Engineers solved this challenge with one of history's most remarkable innovations, the cantilever bridge. Instead of building from the middle outward, massive sections were constructed from both sides, extending farther and farther until they finally met in the center. Huge steel frameworks balanced enormous forces while supporting themselves throughout construction, an achievement that amazed the world. One of the greatest examples is Scotland's Forth Bridge, completed in 1890, which remains one of the strongest cantilever bridges ever built. These extraordinary structures demonstrated that careful engineering could overcome obstacles once considered impossible. Cantilever bridges became symbols of human determination, allowing railways and highways to cross vast waterways without interrupting the rivers below. Suspension bridges. Few structures capture the imagination quite like a suspension bridge. With graceful cables stretching high above deep rivers, wide bays, and dramatic mountain valleys, These bridges appear almost to float in the air. Their secret lies in enormous steel cables, anchored securely into the ground and suspended between towering supports. Smaller vertical cables hang from the main cables, carrying the roadway while distributing its weight evenly across the entire structure. This ingenious design allows suspension bridges to span distances that would be impossible for most other bridge types. Famous landmarks, such as the Golden Gate Bridge and the Akashi Kaikyo Bridge, demonstrate how engineering and beauty can exist together in perfect harmony. Beyond their striking appearance, suspension bridges connect major cities, support millions of travelers each year, and withstand powerful winds, earthquakes, and changing weather. They stand as enduring symbols of human ambition, linking places once separated by seemingly insurmountable natural barriers. Cable-stayed bridges. As engineering continued to advance, designers searched for a bridge that combined exceptional strength with elegant simplicity. The result was the cable-stayed bridge, a structure where straight steel cables extend directly from tall towers to support the roadway below. Unlike suspension bridges, which rely on massive main cables draped between towers, cable-stayed bridges distribute weight directly through their supporting pylons. This design requires fewer materials while remaining incredibly stable, making it an ideal solution for long river crossings and busy urban highways. Their distinctive fan-shaped or harp-shaped cable patterns have become symbols of modern architecture in cities around the world. Famous examples such as the Millau Viaduct in France and the Russky Bridge in Russia demonstrate how these bridges combine engineering precision with breathtaking beauty. Today, cable-stayed bridges continue to define skylines, proving that practical infrastructure can also become a work of art admired by millions. Movable bridges. Not every bridge is meant to remain still. In many busy ports, rivers, and canals, ships need to pass just as frequently as cars and pedestrians. To solve this challenge, engineers created movable bridges capable of lifting, swinging, or rotating whenever large vessels approach. Some bridges raise their roadway high into the air, while others pivot sideways or split into two sections that open like giant doors. These remarkable mechanisms have connected waterfront cities for centuries without interrupting maritime trade. Historic drawbridges once protected medieval castles, while modern bascule, swing, and vertical lift bridges continue to serve some of the world's busiest waterways. Watching thousands of tons of steel move smoothly with incredible precision remains one of engineering's most fascinating sights. Movable bridges demonstrate that flexibility can be just as important as strength, allowing both land and water transportation to coexist efficiently. Viaducts. Sometimes the greatest obstacle is not a single river, but an entire landscape. Deep valleys, rolling hills, wetlands, and crowded cities can make transportation extremely difficult. Instead of building many small bridges, engineers developed the viaduct, a long series of connected spans supported by multiple piers that carry roads and railways across vast distances. Ancient Roman builders first constructed impressive stone viaducts to transport water through aqueducts and connect expanding road networks. Today, modern viaducts built from reinforced concrete and steel allow high-speed trains and highways to cross mountains, forests, and urban environments with remarkable efficiency. Some stretch for several kilometers, appearing to float gracefully above the landscape while minimizing disruption to the terrain below. Viaducts are among the largest transportation structures ever built, quietly connecting cities and regions while overcoming geographical barriers that once seemed impossible to cross. Smart bridges. The bridges of tomorrow are becoming far more than steel and concrete. Hidden within their structures are thousands of intelligent sensors that constantly monitor movement, temperature, vibration, wind, and structural stress every second of the day. Instead of waiting for visible damage to appear, smart bridges can detect tiny changes long before they become serious problems, allowing engineers to perform maintenance earlier and improve public safety. Some modern bridges are powered partly by solar panels, while artificial intelligence analyzes real-time data to predict wear, manage traffic, and extend the lifespan of the entire structure. Future designs may even communicate directly with autonomous vehicles in smart cities, creating transportation networks that are safer and more efficient than ever before. From simple rope crossings built by hand to intelligent structures guided by artificial intelligence, the evolution of bridges reflects humanity's endless determination to connect people, overcome obstacles, and build a better future.